Hello, everyone, and welcome to this new episode of StarkNet, a podcast where we discuss things that get us excited about tech in general and about rollups and StarkNet in particular. Today, I'm joined by Marcello. Hi.
Hey. Thank you for asking me.
I'm happy to have you. And we're going to talk about what Marcello is building and what kind of projects get him excited these days. So, Marcello, you are, I would say, a prominent builder on StarkNet in the sense that you were very active in the dev community. You were very active at hackathons. You participated, you judged. But how would you introduce yourself in what it is you do?
So what I do, I would say definitely I'm one of the builders there. What I do right now, I'm building Herodotus, which essentially is an idea of how to leverage storage proofs with CK and light clients, and that all together to essentially unshard Ethereum, because I believe Ethereum is sharded nowadays. And I think I would sum up myself as the unshardo, however that sounds.
Uncharted? What do you mean? Unsharding?
Yes, I'm unsharding Ethereum.
Oh, in the sense that you're taking multiple shards and making it only one.
Sort of, yeah.
Ah, nice. One network to rule them all.
Not really one network, but the idea is that I can literally inject some state from one chain to the execution on another chain. And this is all like verified by these proofs.
The analogy that popped into my head when I was thinking about storage proof was CRISPR-Cas9, but for blockchains. You get to take the state of a specific blockchain and inject it wherever you want in another blockchain.
Yeah, that's sort of the idea.
Pretty cool. So we'll talk about this in a sec. Can you tell us a bit more about what's your background? What did you study initially?
Okay, so in general, my background, how I got into crypto, or my history about myself.
Story about yourself. Like, what did you study? Like, there was a you before crypto, right?
So actually, maybe I would say that I got into crypto while I was in high school. So I used to study in Poland. And I think that was the first year, or like even before high school, I got somehow into crypto. I started to build stuff around the second year. It was almost 6-7 years ago. So
you started building stuff at that point?
Yes.
What kind of stuff?
Oh, so actually it's very funny because before I used to do hardware and stuff, and at some point I realized that I want my machines to communicate, and I discovered asymmetric cryptography because this sounds like the best way to do that in a secure manner. As I was working in C and C++, I was looking for some SecPK1 implementations, and then I found Bitcoin Core. I was, so Bitcoin's about cryptography. Oh wow!
So you had heard about Bitcoin before, and working with SecP, you figured, it actually uses interesting stuff that I'm using also.
I mean, the first time I heard about Bitcoin, I absolutely ignored it because on-ramping at that time was just too hard, and I was like, okay, it's this weird currency that you use in dark web and stuff, and then when you install the Onion browser, you essentially see some Bitcoins, and I was like, okay, but how do I get them? And essentially, that's where I stopped. I made some reading what Bitcoin is and stuff, but didn't really get interested. The only exciting part was that you can actually build stuff, and you can build payment systems and stuff without any permission. That was kind of fascinating, but I stopped there, to be honest. And then I started to implement this cryptography based communication, and I stepped upon Bitcoin Core, and then I was like, oh, okay, so this is how it works. Started being more and more, and then I got into the Ethereum rabbit hole. And
how did you get into Ethereum?
It was for Bitcoin. So essentially, once I discovered what you can do with Bitcoin, how it really works, it kind of happened naturally that I discovered Ethereum. I started to read more and more, and then I was like, a virtual machine with a consensus under the hood. That's interesting. You can actually do stuff with it, and that's it.
And was it live at the time or not yet?
It was already live. I think it was late 2016 or early 2017. or 18, don't remember. But it was already live at that moment.
Super
but I
cool.
remember these were like the first versions of Solidity, it was a pretty horrible language at the time.
Reminds me of something.
Yeah.
Yeah, no, and also and same thing again. Aside from the language, the tooling was harsh. There would be bug all the time. You couldn't find the issue, and even if you managed to find the issue, probably the answer was 6 months old and not accurate anymore.
Yeah.
So when you heard about Ethereum, did you start tinkering with it? You seem like the kind.
Yeah, but actually I started the wrong way because, like I said, as I was in high school at that time, for me, like writing code was more like was definitely a hobby. I didn't treat it seriously at all, and for me, okay, I know how to code. Maybe I will find a job and stuff. That was like my thinking back then, and then I like discovered Ethereum and stuff, and I was but actually I can do some meaningful things on top of that. And I started to implement some arbitrage bots, which eventually started to work. And I was doing arbitrage, for example, between Ether Delta and centralized exchanges. And that's what made me like learn Solidity in a proper manner.
That's pretty cool. You mean that you did arbitrage between centralized exchange and Ether Delta? Ether Delta was not a pool at the time, right? It was a centralized exchange. It was an order book.
It was an order book on Ethereum. Extremely inefficient, but that was fun. It was very inefficient, like in price discovery, and that's what led to arbitrage opportunities.
So wait, you wrote your arbitrage bot as smart contracts, or did you learn Solidity by reading it and sending transactions to a smart contract to settle arbitrage?
So essentially, I was interacting with Ether Delta through EOAs at the beginning. So essentially, if I wanted to buy and sell, I would just do two transactions, right? And probably one of them would end up in a different block. And that way I sort of learned how Ethereum really works and how this like transaction life cycle is and what you can actually do with the EVM. And then I was like, okay, so I can budget things together. I can have some sort of extended logic and sophisticated logic on top of that. And that's how I actually had to learn it.
How did you explain that to your parents at the time? You were still in high school.
I don't know. My mother probably still thinks I work for Bitcoin. I don't know.
Yeah. Sometimes it's weird to find like you get into the rabbit hole and communicating with the people on the surface is not that easy.
Yeah. Yeah. But I think that the intuition I was able to give it is essentially some sort of high frequency trading and running strategies, just this like open source landscape where you can do whatever you want and you don't need any permission.
Very nice.
Like I think the most beautiful thing about it.
Yeah, that's pretty cool. And so you got into the Ethereum rabbit hole by writing these bots, and I'm guessing that at some point probably you started communicating with people, right? And you started getting involved in some kind of forum or anything, or did you do everything on your own?
Actually, that's a good question. So I started on my own. Obviously, I don't remember actually how I started with Solidity, like what was my first resource. I remember I was like pretty active on asking very stupid questions on Ether Stack Exchange, like Stack Overflow for Ethereum. I remember I was asking like pretty weird questions there and like reading issues on Geth and stuff like that. And that's how like I discovered, okay, some people actually use it and the community is quite significant. Yeah, I think that's it. And then I started to attend some actual meetups in 2018.
Do you remember the first time you met some people who were into crypto in real life?
Actually, no. But I remember my first hackathon.
Oh yeah, where was it?
So it was called HackIF.
Mm-hmm.
It was in early 2018 in Warsaw. And actually I took the third place as far as I remember. And by the way, it was about proving such a bullshit is like putting significant data on the blockchain, because I remember that was like the narrative. Yeah, let's build Dropbox on the blockchain. Let's build, Imgur on the blockchain, stuff like that. And essentially, I took a Lambo picture. I chunked it. I put it on the chain, and that way I've proven that it costs more to actually upload a photo of a Lambo than actually the Lambo itself. Yeah,
Interesting POC. I mean, it sounds like bullshit now, but back then we didn't know. I think that's part of
yeah,
what makes these things exciting, right? We don't really know where we're going
yeah.
all the
It's
time.
funny to see how the narratives change, but in
Yeah,
a
for
positive
sure.
way, obviously.
I think hackathons are a great way to, start and test new ideas. They're also a great way to meet people. Did you meet any people there that you ended up working with after that?
So I definitely got into that community, and like I discovered that some projects actually exist. Like for example, I was not aware that 0x existed, even though I was like doing ARBs and stuff. But I was like, I did a bit later because at that time I already stopped like running the spots. Um, I would say, yeah, it was kind of helpful because after a few months after this hackathon, I went to my first ETH Berlin, and then I started to recognize these people. Like I realized such a global community it is.
Super cool. And so when did you finish high school, if I can ask?
Um, I think 2020, like when COVID started.
Nice. Did you start working right after, or did you move on to study things, or?
So I was doing some sort of consultancy jobs, like doing some very simple contracts, deploying on some weird chains. And that was like when I was already in high school. Then I finished. I continued this. I started university, and I dropped out after literally 4 months. And
Was it not interesting?
yeah, I mean it was pretty boring.
What kind of track did you try to follow?
It was computer science with management.
Okay, cool.
Yeah.
So you dropped out, and what more interesting stuff did you start doing?
Then I joined actually Nethermind,
Okay.
and also before I was already experimenting with Zinc, a bit with Circom, and getting deeper into the ZK rabbit hole. Actually, I cannot
So
say
wait,
getting deeper. I discovered its existence. Cool.
nice. But wait, so Circom is for zero knowledge proof. Zinc is, if I recall correctly, the provable language of ZK sync, right?
Exactly. Exactly.
So it's not oriented towards privacy, it's oriented towards scalability, right?
Exactly. Exactly.
Cool.
And
How did you
from
hear
Zinc,
about these?
uh, actually, I think it was during one of the meetups. I think I met. At that time, I think I met Remco from 0x that told
Hmm.
me that this is like the big new thing. Then I forgot about it, and somehow I found Mother Labs out of nowhere, like on Twitter somewhere. And then I like discovered, I started to play around it, and then I discovered Cairo and stuff, and that was also super exciting, and that's how I got here actually.
Uh, what got you excited about Cairo and these languages?
That instead of writing circuits, you like literally write a program, and it was like an easier intuition to get, honestly.
I see what you mean. Yeah, so when you use can you describe a bit this difference between how it is to write something with, say, Circom and how it is to write something with Cairo? Like what exactly is the difference?
So when you write Cairo, you kind of use the same mental models. You only keep in mind that like the memory is immutable and so on. Like there are some nuances, but overall the intuition is I don't want to say pretty much the same, but there are some similarities. Whereas with writing Circom, it's like pretty low level because you operate like on the signal interface and almost there. So it's a bit different, like seriously different. Yeah.
Is it am I interpreting this wrong, that when you're designing when you write an application with Circom, it's kind of like if you wanted to make an application and you had to design the hardware and the software,
Yeah.
whereas Cairo, it's a general
Yes.
hardware you can use and you just have to write the software.
Yeah, that's a great intuition.
Cool. Okay, so it saves you time on writing the software, which is pretty
Yeah.
great. I agree
Yeah.
with you. Cool. And so when you started to get into Cairo, one of the thing you mentioned it earlier that you're very active in is storage proof. How did you end up working on storage proofs? How did the concept first emerge?
So actually, when I started with Solidity and so on, always my biggest problem was data. So at the beginning, I was not like really aware what is a pattern and what is an anti-pattern. And for example, I was not using events indexers, right? And I was always struggling, how do I feed now some meaningful information to my UI? So I was like putting everything in the state, and then, I wanted to run some sophisticated logic on the smart contract. And for that reason, I needed this historical data. But anyways, maybe coming back to the boss and stuff, at some point, I actually wanted to automate this process. So an actual smart contract could manage, let's say, the money that was held on chain, because I had just a script that was like managing, using an Node.js script or Python script, and I wanted to automate it to do some sort of like DeFi pooling. And I discovered that like managing in general historical events is like pretty complex. And actually, this discovery led me to how the database is structured, Merkle-Patricia tree, and stuff like that. How it really works under the hood. And I think that at some point, I meant I had to access historical base fees for one of the projects I was working on, and and I think I sort of reused this mental models. And then actually, once StarkNet started, like I realized, okay, nice, we have finally an L2, but all these L2s do not give you access to the state on the one, which kind of seems natural, right? Because if we can inherit like the security of the base layer, there must be like a way to inherit also the context of it. And then I started like to experiment what we can do, sending messages. Okay, it's fine, but like it's pretty inefficient. Something you should rather avoid. And essentially like using these techniques and the ability to verify these proofs for very cheap actually makes this feasible.
So
And I think that was like,
how would you define storage proof? Because this is so. If I understand correctly, you were writing your arbitrage bot, and you needed to have access to some kind of historical data to have it be more
oh,
automated.
but I'm not saying that I solved this problem at that point.
No, of
I
course.
just surrendered.
Oh, it's the most beautiful problems are this one. You keep running after them, and doesn't matter where you get, but you learn stuff along the way.
Yeah.
So you started getting into how to store data efficiently and how to reuse data. And as you mentioned, it's very expensive to store data on Ethereum. And so one way to do that is basically to have a proof that something happened in the past on a chain and reuse that. And so storage proof, in a sense, are this. It's a way to show that something happened. There's something interesting about storage proof also, which is that it gives you the ability to revive something that happened in the past, even if this was not meant to be revived, in the sense that, you're at any given height on Ethereum, the block hash contains entropy of basically everything that happened at some point in the chain. And so if you're able to say, look, this event that happened 2 years ago, and you have no way of accessing it in your smart contract, you can actually link it to the current block hash, but it would cost you a lot of money because computation is expensive on Ethereum. And so
and
you're
also
using...
these proofs are also expensive.
What do you mean?
So Merkle-Patricia trees are like a data structure that allows us to like cryptographically commit anything that is inside them. And well, these proofs are like pretty huge. Like they can be 700 bytes. So putting that inside the L1 call data is like pretty costly. However, now with ZKPs, we can kind of get rid of this aspect. And first of all, we get, I don't want to say cheap computation, but cheaper computation than on the one. And most importantly, we can remove this call data aspect and essentially optimize it a lot, especially on rollups like StarkNet, where call data is almost free.
Yeah, I was thinking, but why should call data be free on StarkNet? What would make it free? what makes it free is that you don't, like, when you're a node and you want to keep track with StarkNet, you don't need to have access to all the transactions that happened in the past to reconstruct the state.
Yeah.
You just need the proof. So
exactly.
It doesn't matter if one given transaction is extremely heavy, because you don't need it once it has been executed.
Yeah.
Right?
Exactly.
Huh. It's actually fun. So storage, we often say storage is expensive, computation is cheap on StarkNet. Turns out that storage is expensive, yes, but some parts of storage, or cold data, for example, can be quite cheap.
Yeah, state is expensive.
State is, for sure.
Yeah.
State is expensive. So I keep referring to your tool built on your storage proof tool as Fossil, but you mentioned that it's now called Herodotus.
I mean, essentially, Fossil was built a long time ago. And it was like this very basic tool to access Ethereum state on StarkNet. However, right now, like, I've seen what is possible by combining, first of all, by using storage proof like widely. And then, slowly I realized that essentially by combining that with ZK proof, like outside of the StarkNet scope, but like in general, and also providing it with light clients, you can literally inject state and context. And essentially, this broader vision is now called Herodotus.
So Herodotus is a proof system, if I understand correctly. You mentioned that you wrote a prover and a verifier, right?
Yeah.
So it allows you to generate, is it Stark proofs?
So obviously the Cairo code can be proven with the shard, right? It's the execution of it, so it will result in a Stark proof. However, I'm also working on some Snark implementations, because obviously verifying a Stark directly on the one, like without batching this computation with some other parties, might be just expensive, right? If, for example, you want your application based on contract, let's say on Ethereum L1 to access some state from Optimus, right? So it would be like pretty expensive to provide the entire Stark and verify it. So for that reason, you want something like more lightweight, like a Snark, where you essentially pay in proving time, but at least the proof is like much smaller.
Yeah, makes sense. Okay, cool. So you're building a set of tools that are both Stark proofs or Snark proof, and that will allow you to prove that something happened on a chain and inject that state in another chain.
Yeah.
What kind of chains are you working on? Is it EVM chains? I saw recently that you put out a tweet that you could do some storage proof between ETH and ETH-POW. Have you actually managed to do that?
Yeah, actually it's live. So just to showcase what you can do with this technology, we actually build a bridge between Ethereum proof of stake and Ethereum proof of work. And the crazy thing about it is that it's live and people actually use it. And I think that overall we had like a few thousands of POW ETH being breached.
That's pretty cool. Congratulations.
Yeah,
Can you explain in a few words how it works?
Oh, it's very simple. So essentially, what you care about when you're building a bridge is how do you really make sure that something really happened on the other side? Because while if you're bridging between chain A and chain B, some token Z, you want to make sure that on the chain A, this token Z had been locked, so you can mint their equivalent on the other chain. However, when you withdraw, we want to make sure that these tokens have been burned, so then you can unlock them. This is like this basic idea. So for me, building a bridge comes back to the problem. How do I really make sure that the claim actually happened? And apparently storage proofs are perfect for it, because in order to like check anything and make sure something really happened, you need this small cryptographic commitment, which is either a state root or a block hash. And against this commitment, you're able to prove any claim. So now the way it works, we relay these messages, so it's not like fully trustless. However, to check that the bridge behaves correctly, it's like literally two lines of code. It's one RPC call to Infura and one call, also RPC call, like to read the state of our contract and check if the relayer relayed the proper message. Otherwise, the UI won't let you use the bridge.
So when you're saying that it's not fully trustless, do you mean Do you mean because you say you only need one small cryptographic commitment to
Yes.
on chain A you need a small cryptographic commitment of what happened on chain B. So for
Yes.
example, a block hash, and
Yes.
then you can infer what happened. But you still, and the not so trustless part is that you still need some kind of oracle to
Yes.
say, hey, this is the hash of chain B, right?
Yes. Yes.
Couldn't you write a proof that verifies proof of work for ETHPO or that verifies Ethereum for the proof of stake for ETH?
Actually, this is one of the Herodotus, a part of the Herodotus vision, that essentially we want to encapsulate light clients into ZKPs. So because if you think what is a consensus, the consensus is about agreeing what is the latest state root. And now if you can compress this logic and have a proof that tells you, hey, yeah, this is the newest state root, essentially you're done. This is the end game, at least for me. But the reason why we could not do that is, first of all, we came up with this crazy idea one day and 22 hours before the merge. Yeah, we had to use like a simpler solution. And also the problem with Ethereum POW light client is that ETH hash, like the hashing function used for proof of work, is very, very memory intense. So it's not something you can run on the EVM in a circuit in Cairo. It's just very, very hard. However, you can execute the proof of work, the proof of stake consensus. This is actually feasible.
So you mean that now that Ethereum has merged, it's easier to generate a trustless proof for its execution than it was before with POW?
Yeah, absolutely.
Really cool. And so your goal is for Herodotus is to have basically, so you mentioned one RPC call there, one RPC call there, and just like have everything rebuild and have your software rebuild everything and generate a proof for it, right?
Yeah.
It still seems to me that there must be a hell of a lot of work to do on the how to use it efficiently, right? How do you use the API, depending on what part of the state you want to access. It must be quite difficult, especially because, as you mentioned, how state is structured in Ethereum is a rabbit hole of its own, and so most people are mostly used to thinking about, oh, I have this variable in that contract, but they don't necessarily know how to map this to how it is stored in storage. So I imagine you must be spending quite a lot of time on this, right?
Yeah, actually, there is a big complexity behind using storage tools directly. And when I built this tool called Fossil, I actually got a significant amount of questions from people who wanted to use it. How to actually use it, right? Because one thing, okay, I can prove a specific storage slot, but how does it link to my variable, to my ERC20 balance? And then I realized, okay, there is a significant problem. So I thought, okay, so what if I do this work for others? And because, well, I can prove that the work I've done is correct, then I can do it in a central manner and essentially manage all the complexities behind. And also part of this vision is to help developers. So they will be able to tell me, hey, I want my ERC20 balance to be proven, and we're gonna prove it for you. You're gonna receive the proof, and then this proof can be literally injected in your transaction. And this would be done like in the background by us.
Okay. So instead of people running their own thing, you would have some kind of, let's say, API service where people would say, hey, I want a proof for this, and you would reply it back.
Exactly.
Cool. How many people are working on this right now? Is it you? Do you work with other people?
So I started myself, and right now we are a team of four engineers.
Very nice.
Yeah.
Super cool. Where are you guys based?
Oh, we are decentralized.
So a bit all around the world?
Mostly in Europe. Yeah, mostly in Europe.
Very nice. And so when do you think people will be able to start experimenting with Herodotus?
So with the actual API, I'm not sure if I should like say.
No, you don't have to commit anything.
In the coming weeks, definitely. Like it's almost there.
Very cool.
The first release, yeah.
Nice. Wow, this seems like it's funny because it's moving very fast. It seems like there's a
Yeah,
lot of things to be
yeah.
built. And what do you think people will build with that? What are use cases of storage proof that you think are exciting or interesting to you?
So maybe I will tell why I think storage proofs are like I don't want to say a new primitive because we've seen storage proofs being used in the past, but
Have we?
without yeah, like for example, Aragon was actually using this storage proofs, Logdani as well,
Okay,
um, like back in 2018, 19. But anyways, again, this was done without ZKPs, so pretty
expensive.
expensive and unfeasible. And I believe that now by having a deterministic consensus algorithm, which is proof of stake, having ZKPs like efficient ZKPs, and finally storage proof, we can really combine this all together and have a very nice new primitive, which essentially for me is like the end goal for interoperability, especially in this new sharded world. Okay, so now about the use cases. So like I said, I believe that Ethereum is sharded nowadays, and I really believe that it will be painful for
Wait,
developers.
can I ask, what do you mean is sharded? What do you mean by Ethereum is sharded nowadays?
So we have many L2s. Most likely we'll see L3s and L4s. And essentially the problem is, okay, we keep talking about the liquidity being split across many domains, but also the state is split across many domains. And this is like a big problem because if you think of what Ethereum was at the beginning, it was like this infrastructure where you could deploy your smart contracts, and these smart contracts could talk to other smart contracts like in a synchronous manner, like straight away, without like this send then receive information, like without this messaging in between. And like I believe this is going to be very painful as it introduces a lot of delays. And like we've seen that on chain, we mostly build DeFi nowadays, and many DeFi applications are very latency sensitive. So I believe it's gonna be a pain right now to build applications in this sharded world. Um, yeah, and essentially, what I think is great about storage proofs is that we can fix it. We can like literally fix it by just changing our thing that instead of reading state, we can inject it. So what are the applications? Probably convenience, and removing this latency. So this is like probably the biggest use case. And also, I think that while building on-chain applications, we got used to this type of thinking where we don't look in the past. If you think of Web 2, like Web 2 is based on data which we keep aggregating and then somehow reusing it. Whereas in Web 3, like we have this very flat model of thinking, which doesn't necessarily need to be true. I mean, it's understandable because we're limited in the amount of computation we could do and also the data we could access for obvious reasons. Because if you wanted to access historical state from any smart contract, it means that every validator in the network needs to be a full archive node, which is a pretty big assumption. And yeah, with storage proof, we essentially, I believe we can unlock a huge amount of new application designs.
Okay, interesting. So you, if I follow correctly, what you're saying is that storage proofs expand the dimensionalities of your contract. It allows you to access state from other chains or
Yeah,
from sharded chains. And when I say access it, I don't mean as just read directly,
yeah,
though you could imagine this, right?
yeah,
But read as in get trustlessly information from other chains. So it allows them to access an expanded state, right? It
yeah,
expands the state your smart contract can use. And yeah, you could actually imagine in your node having some kind of API. Like you could imagine having a node that offers the service of, hey, you want to send your smart contract and just generate a proof automatically. When I see that you're trying to access some storage on Arbitrum, I'll just generate a proof for it and inject it there.
yeah,
Um, so it expands both the state your smart contract has access to, and it also extends time sensitivity. It gives access to your smart contract to things that happened in the past. So it gives
yeah.
it's not memory, but it gives the network more self-awareness as to what happened in the past. Which is kind of a funny thing to say. The network is becoming more self-aware.
Yeah.
But that's pretty cool, right? It gives you a lot of tool to analyze historical state or data or a lot of things. Something I realized recently is that you could use storage proofs to retrieve the content of op return UTXOs on Bitcoin and prove what was done there.
Yes.
And I think that's a fascinating concept. So op return is an opcode that allows you to basically put the hash or put 80 byte worth of information, whatever it is you want. Most people will do a hash, and some people use it to say, for example, timestamp a musical creation or some artwork or whatever it is you want. In a past company, we used Bitcoin to put the hash of a Geth chain that we were running privately.
Nice.
And when we were doing this at the time, we were like, okay, I mean, this is something that is interpretable by human. You can prove that your chain was not altered, or at least that it existed in some state in the past, but you can't really do much with it, really. But now with storage proof, you could actually prove that you did something in the past and make it enforceable and give it teeth. And to me, it's kind of like I think of it as I think of the Voyager spacecraft that we sent somewhere out very far in the cosmos. And at the time, it was sent in the 70s, and we put a bunch of recollections and all our hopes and all our basically who we are into this spacecraft, which we sent. And they're the farthest object that was sent by mankind that is outside of the solar system. But maybe someday we'll catch up with these, and maybe someday we'll be able to get there and reuse this, even though it was not meant to. And to me, storage proof are kind of the same thing, but for the blockchain world, right? Something happened a while back, and it's not something that was meant to be reused, but there is some value or some interesting stuff to be derived with. And storage proof allows you to basically say, yes, this happened. You can reuse it, which is super cool.
Yeah. And I think this is like a pretty nice characteristic of blockchains in general, that everything that happens there is cryptographically committed, which is a pretty unique thing, actually, when you think of it deeper.
Yeah, it's the first historized version of the web, right?
Yeah.
Yeah, it's a really interesting primitive. I'm really curious to see how these things evolve and how, I mean, what people will build on top of it and the impact it will have on how we interact as a society as a whole.
Yeah.
Anyway, that's super cool. I think I've asked most of the question I wanted to ask you. Maybe one thing I wanted to ask is, you mentioned that you've been in the space for a fairly long time. What are some things that you saw that changed for the good and for the bad? What, like, according to you, what are things? What things changed?
So now, to be honest, I'm seeing like a breakthrough in how we build things. So this is mostly like the rise of ZKPs. And like in general, this cryptographic primitives, like primarily ZKPs, but also I think that multi-party computation is still a bit undiscovered and might offer quite a lot. And I'm like pretty excited about what the future will bring, because we literally are starting to have these primitives and this low-level infrastructure that will enable completely new applications. But not only in Web3 actually, but even in Web2. If you think of it, like it's really fantastic. Like it's I would say it's a breakthrough in computer science in general.
What do you have in mind?
The fact that we can actually do provable computation, like this is fantastic.
I agree with you.
And also now multi-party computation. Also, for example, we can do something together, and we cannot collude in any way. We could actually even prove that what we made all together without revealing how we made it is correct. Like it's this concept is just mind blowing.
I agree with you. It's fascinating.
Yeah.
Okay, Marcello, thank thank you a lot for your time. This was a really insightful conversation. I'm really looking forward to see how we can use Herodotus to build cool stuff. Where should people go if they want to read more about this?
So Herodotus.dev, as I mentioned before, in the next couple of weeks, we are going to be live with our APIs. We'll pull a significant amount of data to StarkNet from different chains, and also soon we'll be able to export StarkNet state to other EVM chains. And most likely it's going to be herodotus.dev/docs.
Very cool. Well, then, call to action to all the devs listening here. If you're interested in about storage proofs, aka CRISPR-Cas9 for blockchain, go look this up.
Oh, and obviously, can DM me on Twitter. I'll be happy to answer any questions.
So where people should follow you on Twitter?
0x Marcello.
0x Marcello. Very nice. Marcello, thanks again for your time, and until next time.
Thank you.
Bye.
Bye.